Hello everyone, this is Maziyar from Spark NLP, and I'm excited to share our upcoming release and all its amazing features with all of you. For those of you who don't know what a Spark NLP is a powerful open source library for natural language processing. It's built on top of Apache Spark, more precisely a Spark ML module, providing a scalable NLP tasks. Since our first release in 2017, it has grown to become the most widely used NLP library in enterprise. What makes a Spark NLP different from other libraries is the ability to serve as a unified and single solution for all your NLP needs. I'm happy to share that we have just crossed 120 million downloads on PyPy. On behalf of me and the entire team, I would like to thank our community who's been with us for the last 7 years. It's been truly an amazing journey. Now, one of the cool things about Spark NLP is the large ecosystem of pre-trained resources. It offers free, forever, and open source pre-trained pipelines and models. It's available on our Models Hub. Now, with this extensive collection, you can quickly implement a sophisticated NLP tasks without starting from scratch. Now, speaking of pre-trained models and pipelines, I'm also happy to announce that we have added over 50,000 new state-of-the-art models to our Models Hub in our upcoming release, to making it a total of 80,000 models and pipelines ready to be used by our users. Similar to Apache Spark, we also support the exact same ecosystem of hardware and platforms. Now, when we could optimize and increase the speed and probably making it better, like Intel, like on AMD or CUDA, we will also add our own secret sauce on top of it to make that integration a bit more native and bring a performance to that hardware and to that platform. Three pillars that we always stick to when we develop something in Spark NLP. First is accuracy. It has to be a state-of-the-art. Second is scalability. It must scale with zero code change. This is like a typical thing in Spark, in Apache Spark. The code you have that runs on a single machine is the same exact code that runs on a cluster. However, just because you can scale it on multiple machines doesn't mean it shouldn't be speed or fast on a single node. So we also wanted to make sure that it's fast or faster than other libraries on a single machine. Now, how easy it is to use? Let's look at the example of pre-trained pipelines. Now you have over 28,000 pre-trained pipelines, simple, ready to use, 1 or 2 lines of code. It works online and 100% offline. You do not need any internet to use any of these models or pipelines. Once you download them, you're good to go. Now, is it all about what we offer? Not at all. You can train your own models. Here is an example of a few lines of code. You can train state-of-the-art name recognition by using BERT embeddings, or you can use any of our 10,000 word embedding models that we have on our Models Hub to train any model you would like. You do that on a CPU, or you can do it on GPU. If you evaluate them, it's usually going to be in top 5. The algorithm we use in our NERDL is one of the top 10 algorithms that is for token classification. Speaking of embeddings, we also have text embeddings, which are very popular these days, thanks to something called RAG, which goes along with the chatbots or LLMs. Let's imagine if you have one of those state-of-the-art AI databases like Weaviate. You have some documents, you would like to extract those documents. The first thing you need is to transform your data into vectors. Now, people have a lot of documents, right? 10,000, 50,000, 10 million. If you have, let's say, PubMed, you have 30 million abstracts, right? With the Spark NLP, you can almost a linear speed enhancement when you add different workers that you can see in the visual by using state-of-the-art embeddings. For instance, here is E5. You can use E5 large, or you can use any other embeddings that we have recently, like Nomic or Snowflake. The thing is that you can always scale them, and the higher you go, the faster you can crunch those and transform them into vectors and insert them to databases to be ready to be used later on in your LLM applications. Now, to just end the introduction to Spark NLP, you can access the website and see over 300 live demos and notebooks, or you can go to Hugging Face, and we have hundreds of spaces ready for you guys to play around. Now, here comes the Spark NLP 5.5, really a game-changing release for us at least. It has Qwen 2, it has mini CPM, it has new embeddings, as I said, Nomic, Snowflake, it has a couple of new classification like zero shots, it has Phi tree, it has missing annotators that they have supporting with Open Reno. They have support for, I would say, vision transformers for Onyx. However, the most important feature on this release for us is the one at the very bottom. It's Llama CPP integration. Now, Llama CPP is really close to my heart, at least personally. Over a year ago, exactly in March 2023, I managed to run the first version of Llama with 65 billion on my laptop. It was truly a game-changing moment for me to be able to bring such a strong AI locally on my laptop. And it took us 1 year and a lot of practice to make sure we can integrate Llama CPP into a Spark NLP. Now, some of you might know me by my work in quantization community. I have made over hundreds of models, quantized them in different sizes. I truly believe that AI and LLMs should be accessible to everyone regardless of the hardware. Now, what does that mean to a Spark NLP? We focusing on LLM inference means that we're natively integrating into Llama CPP, giving you the opportunity to bring tens of thousands of GGUF models into your environment. Now, thanks to the CPP and their flexibility in deployment, it's also hardware agnostic approach. What does that mean is that Spark NLP already supports CPU, both Intel AMD. It supports ARC64. It supports Silicon on Apple devices. Also support CUDA. It matches perfectly with the same ideology of Llama CPP. Now, very quick introduction to what Llama CPP is. It's a library developed by Georgy Gerganov. It focuses on LLM inference, but with the minimal setup and also a state-of-the-art performance. It supports a wide variety of hardware from local setup all the way to cloud. And one amazing thing it has is a state-of-the-art quantization algorithm. You can quantize and reduce the size of the model from 32 to 16, 16 to 8, to 4, to 3, to 2, or all the way to the 1 bit, which means that you require less memory, meaning that if you're on GPU, you require less VRAM. If you're on CPU, you require less system RAM, right? And that's what it means to have a GGUF model in a different sizes, 4 bits or 8 bits. Now, it fits perfectly with a Spark NLP. As I told you before, we already support Intel processors, we already support NVIDIA CUDAs, we already support Apple Silicon chips. We focus on performance optimization for any of these hardwares on any platform. Now, speaking of platforms, the scalability and deployment options we have, it's from your local machine, your usual Jupyter, probably Google Colab, Kaggle, doesn't matter, all the way to single node setup on Databricks, for instance, multi-node clusters, let's say you're on AWS EMR, or you're on Azure Insight, or on GCP, and so on, right? Even you're on Kubernetes. Now, how does it look like and how does it work? This is how it looks like. Very simple. For the first time ever, we made one annotator for all the possible architectures. All you need is auto GGUF model. You just put the name of the pre-trained model into that annotator, and you have all the parameters one can expect from Llama CPP, and that's it. Obviously, before that, you have to have document assembler, which is the first annotator in any pipeline that you want to have with the Spark NLP. You could have your chat template for the text. It's up to you. However, the model itself and the annotator itself is dead simple. Now, how do we scale this and what the speed about that? Let me show you some numbers. So we put CPU and GPU next to each other. One thing immediately you would notice is that we use somewhat high-end CPUs. They're a bit expensive, 30 core, 64 gig RAM. It's only one machine, right? And we use the latest Llama 3.1, just came out like a month ago. And for the task, we said, let's translate news headlines to German, right? That was the task. So from 10,000 prompts, we got almost 44 tokens per second when we were on the CPU. With a GPU, because it's GPU, instead of 10,000 prompts, we throw 100,000 prompts. Why? Because we expect more from GPU. Same situation, create 100 tokens and do the exact same task. And you can see we almost reached 387 tokens per second. Now look at the GPU, it's T4. T4 is the minimum smallest GPU device available on AWS. I think it's T4, it's 12, 14, or 16 gig VRAM. Then it's A10, A40, L40, L40S, A100, H100. It's the cheapest minimum GPU you can find, right? And even that, it's in almost 9 times faster than CPU on a load that is 10 times more, right? So that is incredible performance to see from such a small GPU compared to such an expensive CPU. Now, what will happen if we put these things in a cluster? What will happen if we say 1 node, 2 node, 5 node, or 10 nodes? We just scale them, either on CPU or either on GPU. Same exact task, 10,000 prompts. Let's see what happens. Now, few highlights from this 2 visuals. First thing first, Spark NLP 5.5 scales exceptionally well, right? It's like near linear speed up as we add nodes into the cluster for both CPU and GPU. Scale efficiency is maintained up to at least 10 nodes that we can see here, right? It's like a potential for handling very large workloads. It means that you can keep on adding. In some clusters, if you add more nodes, the communication becomes more cumbersome. So you can see that it's not linear scaling, right? But here you can see you can still have at least to add more nodes into a cluster. So both CPU, GPU setup show similar scaling characteristics. So it's giving you the flexibility in your hardware choices, which is beautiful. So if you would see different scaling, you would have to be limited or forced to choose CPU over GPU or GPU over CPU. But since they are both near linear, you have the choice to pick your device based on your budget. Now the time might be similar kind of, because you can see it's like 10K, 10K, but you can see GPU and the GPU is almost 9 times faster than CPU on every single situation, whether it was 1, which we already saw that, which is 2 nodes, 3 nodes, 5 nodes, and 10 nodes. So the visualization, they look similar, but if you look at the minutes, one goes all the way to 400, and the other one goes actually to 40. Now, what can you do with this kind of offline LLM inference, right? So some of the practical applications that I personally use myself, I do a lot of text translation, and these LLMs are great for translation. We do have an extensive number of models that they do translation, but these large language models, especially if you can instruct them to make a bullet points for you, to make a conclusion for you while translating, this flexibility is priceless. Sentiment analysis, let's say you have a large amount of social media data. Let's say you want to be flexible in terms of extracting name recognition labels from legal documents, right? Question answering system, if you have customer support text, you can do text summarization, you can do intent classification, document classification, and one very, very important task that you can apply is syntactic data generation, meaning that you have a prompt, you have an answer, and you can entirely create a new answer in offline. Now, keep in mind, the only product that is similar to what we've done here in the Spark NLP 5.5 is the batch API in OpenAI, where you just put your prompts, put your tasks, and then you go a day after and you get the results back. So what we've done is similar to what OpenAI has done. Now, please join our community. Go to our GitHub, create issue, create feature request. You have discussions also in the GitHub. Read the documentation. We have regular webinars and workshops. Please check the websites. These annual NLP summits are great to see all the open source around AI and deep learning. We have training and certification programs as well. You can check on the website to get more details on that. Thank you so much for your time. I appreciate it. Have a great day.